Welcome to the session number 8 from the playlist of NEET Physics Part 2. The topic for the today's session is electric flux and the Gauss law. And the question which I have taken for this session is based on this topic, that is electric flux and Gauss law, and it was asked in the cbse All India Pre-Medical Test in the year 2007. So here the question is, a hollow cylinder has a charge Q within it. So this was the figure which was provided along with this question. So this is a hollow cylinder and it has got a charge Q within it. So this is the charge Q which is lying within this hollow cylinder. Now if phi is the electric flux associated with the curved surface B, this is the curved surface B of this hollow cylinder. So if phi is the electric flux associated with the curved surface B, then the flux associated with the plane surface A is given by. So there are 4 options given here and we have to find the correct one. So this is the plane surface A in this figure, and this C is the and this one is the plane surface C. So in this question we have to find the total flux which is associated with the plane surface A. Now as we all know that this is the positive for the positive charge, the electrical field lines are always directed away from the charge like this. So, and the second important thing is that the flux through a closed surface is taken as positive if the electric field lines are leaving the surface. And the flux is taken as negative if the electric field lines are entering a surface. So in this case, we can see that the electric field lines are leaving from the surface A, from the surface C, and from this curved surface B. So the flux which will be associated with this curved surface A, C and B will be taken as positive. Now the total flux which will be associated with this hollow cylinder will be equal to phi A plus phi B plus phi C, where phi A is the electric flux associated with this curved surface with this plane surface A, and phi B is the flux associated with this curved surface B, and phi C is the electric flux associated with this plane surface C. So now here the cross sectional area of A and C are equal. Therefore the flux associated with the curved surface A will be equal to the flux associated with the curved surface C, or you can say the flux associated with this plane surface A will be equal to the flux associated with the plane surface C, because flux is given by the relation E as cos theta, and this is equal to Q upon epsilon naught. Flux is equal to E as cos theta, and this is also equal to Q upon epsilon naught, where E is the intensity of the electric field, S is the surface area, and theta is the angle between the direction of the electric field and the normal to the surface. So in the case of A and C, the surface area is equal, the intensity of electrical field will remain the same for both the surface, and theta in this case will be equal to 0 degree, because the direction of the electrical field is as indicated by this arrow, and the normal to the surface will be as indicated by this arrow. This is the normal to the surface. So the angle between the normal to the surface and E will be equal to 0. So in this case, phi A will be equal to phi C, and this will be equal to E into S, where S is the surface area of this curved surface A and the curved surface C. So in this case, the flux associated with the curved surface A and the curved surface C will be equal. and the total flux will be given by the formula which is written here, that is phi A plus phi B plus phi C. So now I have to find the total flux associated with the this surface A. So the total flux here is equal to this. Now phi A. Now since phi A is equal to phi C, or you can say since the flux associated with the curved surface C is equal to phi A, so I can substitute phi C as phi A, and the flux associated with the curved surface B is equal to phi. So this will be written as phi. Now as per the Gauss law, the total flux associated with a closed surface is equal to the charge enclosed by it divided by epsilon naught if this hollow cylinder is lying in free space. So if we consider that this hollow cylinder to be lying in free space, then the total flux associated by this this hollow cylinder will be equal to Q upon epsilon naught, where Q is the total charge enclosed by it and epsilon naught is the permittivity of free space. So using this Gauss law, the total flux associated with this hollow cylinder will be equal to phi A plus phi A plus phi, which will be equal to Q upon epsilon naught. So here the total flux was equal to phi A plus phi C plus phi, but since phi C is equal to phi A, therefore I have substituted the value of phi C as phi A in this in the total flux. So phi A plus phi is equal to Q upon epsilon naught. So from here I am getting this 2 phi A is equal to Q upon epsilon naught minus phi. Or we can say that the flux associated with the plane surface A will be equal to 1 by 2 Q upon epsilon naught minus phi. So the correct option here will be A. So here in this question, the most important thing which you all have to remember is that the flux associated with any closed surface is taken as positive if the electrical field lines are leaving the surface, and it is taken as negative if the electrical field lines are entering the surface. This is the most important thing which you have to remember. And then we have applied the Gauss law, that is the total flux associated by a closed surface is equal to Q upon epsilon naught. So thank you very much for joining this session, and in the next session I will be coming up with a different topic, but the chapter will remain the same, that is the electric charges and field. So till then, have a nice day. Bye.